this video, we are going to solve a sample problem in Chapter 6, V4 in gas power cycles. Problem 6.1. The ideal diesel cycle. An ideal diesel cycle with air as the working fluid has a compression ratio of 18 and a cut-off ratio of 2. At the beginning of the compression process, the working fluid is at 15.3 psia, 90 degree Fahrenheit and 117 cubic inches. So, utilizing the cold air standard assumptions, determine A. the temperature and pressure of air at the end of each process, B. the net work output in the thermal efficiency, and C. the mean effective pressure. So, we have here the given from the problem. The ratio is equals to 18, and then the ratio C is equals to 2. P1 is equals to 15.3 psia. The temperature is equals to 90 degree Fahrenheit. So we're going to convert this to Rankine. So we have 90 plus 460 is equals to 550 Rankine. And our volume 1 is equals to 117 cubic inches. So we have here the solution. So to solve for V2, we're going to use the formula. V2 is equals to V1 over R, so we have 117 cubic inch over 18, so we have V2 is equals to 6.5 cubic inches. And for V3, we're going to use this formula, so we have the RC is equals to 2 times the V2 of 6.5 cubic inch, so we have V3 of 13 cubic inches. And for our V4, we have V4 is equals to V1 is equals to 117 for 117 cubic inches. So process 1, 2, isentropic compression of an ideal gas constant with specific heats. So we have here T2 is equals to T1 times V1 over V2 raised to K minus 1. So we have T2 is equals to 550 Rankine times 117 cubic inches over 6.5 cubic inches times raised to 1.4 minus 1. So our T2 is equals to 1747.72 Rankine. And for our P2, we are going to use this formula. P2 equals P1 times V1 over V2 times raised to K. So we have 15.3 pound per inches squared times 117 cubic inches over 6.5 cubic inches raised to 1.4 minus 1. So we have 15.3 pounds per cubic inches times 18 raised to 1.4. So our P2 is equals to 875.13 psia. Process 2 to 3, constant pressure, heat addition to an ideal gas. So P3 minus P2 is equals to 875.13 psia. So to solve for T3, we are going to use this formula. P2 times V2 over T2 is equals to P3 over V3, P3 times V3 over T3. So T3 is equals to T1 times V3 over V2 is equals to 1747.72 Rankine times 13 cubic inches over 6.5 cubic inches. So our T3 is equals to 3495.44 Rankine. So for our process 3 to 4, isentropic expansion of an ideal gas constant specific heat, we have T4 is equals to solve for T4, we are going to use this formula. T4 is equals to T3 times V3 over V4 raised to K minus 1. So we have 3495.44 Rankine times 13 cubic inches over 117 cubic inches raised to 1.4 minus 1. So our T4 is equals to 1451.46 Rankine. And next for our pressure 4 or P4, we are going to use this formula. P4 is equals to P3 times V3 over V4 raised to K. So we have 875.15 psia times 13 cubic inches over 117 cubic inches raised to 1.4. So our P4 is equals to 40 psia. So for B, the net work for a cycle is equivalent to the net heat transfer. But first, we will find the mass of the air. So we are going to use this formula. M is equals to P1 times V1 over R times T1. So after that, we're going to substitute the given value. So we have 15.3 psia times 117 cubic inches over 0.3764 psia times cubic feet per lbm r times 550 r. So we have to convert this. So we are going to multiply to cubic feet and 1728 cubic meter. So cancel the same unit, cancel. So the mass of the air is 0.00509 lbm. So for our process 2 to 3, we are going to solve for Qn. So Qn is equals to m times h3 minus h2 equals mcp times t3 minus t1 t2. So we have 0.00509 lbm times 0.240 btu per lbm Rankine times 3495.44 Rankine minus 1747.12 Rankine. So our Qin is equals to 2.135 BTU. And for our process 4 to 1, we are going to solve for Q out. So Q out is equals to M times V4 minus V1 equals MCB times T4 minus T1. So you have 0.00509 lbm times 0.117 BTU 0.171 rather BTU over lbm Rankine times 1451.46 Rankine minus 550 Rankine. So our Q out is equals to 0.785 BTU. And next we're going to solve for our W net. So we have this formula, W net is equals to Qn minus Q out. So our Qin is equals to 2.135 BTU minus 0.785 BTU. So our W net or work net is equals to 1.35 BTU. And next we are going to solve for our efficiency. So to solve efficiency, we are going to use this formula. Efficiency is equals to W net over Q in. So we have 1.35 BTU over 2.135 BTU. So our efficiency is equals to 0.632 or 63.2%. And lastly, we are going to solve for our MEP. So we are going to use this formula. MEP is equals to W net over V max minus V min equals W net is equals to V M over V1 over V2. So we have 1.35 BTU over 117 cubic inches times 6.5 cubic inches times 778.17 lbf feet over 1 BTU times 12 meter over 1 feet. So cancel the same unit, cancel. So our MEP is equals to 114.08 psia. That's all for today's video. Thank you for watching, guys.